All right, okay, so this is January 2020, question number 5. It says a group of 100 students estimate the mass in grams of a seed. The cumulative frequency curve below shows the result. All right, so this is the cumulative frequency curve. Just some things to point out is that n is equal to 100 because there were 100 students, so n is equal to 100. This is n over 2, which is 50. This is, all right, let's stop there for the time being and continue the question. All right, the first thing we're asked to do is that it says using the cumulative frequency curve, we're to estimate the median. Now, the median would be the value of the n over 2 student. Now, in your cumulative frequency curve, all right, someone say with students, yeah, students. In your cumulative frequency curve, on the left, sorry, your vertical axis, you have cumulative frequency, and cumulative frequency is the number of students. So this curve is showing the value or the mass that was given by the 100 students. That typically every point on this curve represents a student and the mass that he estimated the seed to be. Now, the median is the what? Is the mass given by the n over 2 student. N is 100, so n over 2 is 50. So to get the answer, this is what you're going to do. At 50, you're going to draw a horizontal line. And where you hit the curve, you're going to then turn and draw a vertical line. So I'm doing that. All right, and so the value is here. This is Q2, which is the median. And from looking at it, it is 3.2 grams. So I would start out by saying that the median Q2 is equal to 3.2 grams. So what is the second thing we're asked? The second thing we're asked is what is the upper quartile range? Now, the upper quartile range, the symbol for that is Q3, and this is the value below which 3/4 of the data lies. This is the value below which 3/4 of the data lies. Now, to find Q3, the upper quartile range, this is what you're going to do. You're going to look for n. You're going to find n multiplied by 3/4. So n is 100, you multiply that by 3/4, that is 75. 75 is in the dead middle between 80 and 70. So right there is where we got 75. At 75, which is 3/4 of n, I'm going to go across. Why 3/4? So there, then now, and we hit the curve, I'm going to go down. This would be much easier to do on actual paper. On the tablet, it's not so easy. All right, so this is, the value here is Q3, which is the upper quartile range. And from looking at it, the upper quartile range is 4.3 grams. So to answer, I'm going to say Q3 is equal to 4.3 grams. The next thing we're asked to find is the semi-interquartile range. The symbol for that is SIQR, and SIQR is equal to Q3 minus Q1 divided by 2. Q3 we already found, so what we need now to find is Q1. Q1 is the value below which 1/4 of the data, 1/4 of the data lies. To find that, you need to find 1/4 of n. Now, n is 100, so 1/4 of n is 25. 25 is in the dead middle between 20 and 30. So that is 25. At 25, I'm going to draw a horizontal line across until it hit the curve. And where it hit the curve, I'm going to go down. And this to me, this would be Q1, and my Q1 look as if it is 2.3 grams. So let's go back to it. All right, so this would be Q3, which is 4.3, minus Q1, which is 2.3, divide by 2. So this is 2 over 2. So SIQR would be equal to 1 gram. The semi-interquartile range would be equal to 1 gram. Next, next we're asked to determine the number of students whose estimate is 2.8 gram or less. We need to find the number of students whose estimate is 2.8 grams or less. All right, the first thing we need to do is to find out which student's estimate is 2.8 gram. All right, let's pause a second. So as I was saying, the first thing we need to do is to find out which student had an estimate of 2.8 gram. That's not difficult to do. At the bottom here, where you have maths, you need to find 2.8. So this is 2.2468. 2.8 is here. You're going to go up at 2.8. And then horizontally going to go across. All right, so this to me look like it is 38. So this is saying the 38 student, his estimate for the mass of the seed is 2.8 gram. Everybody above him believe it to weigh more than 2.8 gram, and everybody above him give an estimate of more than 2.8 grams, and everybody below him give an estimate of that is less than 2.8 grams. So my answer to this question would be all right, so let's get to the answer. So my answer to this question would be is that the number of students whose estimate is 2.8 gram or less, number of students that says the mass is less than or equal to 2.8 grams is equal to 38. So the 38 student says the mass of the seed is 2.8 grams, and everybody below him says it is less than 2.8 grams. So the number of students that says the mass is 2.8 grams or less is 38. Continuing. All right. This is the point this is the part of the thing I didn't think was very clear. It says use the cumulative frequency curve on page 18 to complete the frequency table below. All right, what we need to do is we need to determine the cumulative frequency curve at 4, the cumulative frequency curve value for 4 and at 6 grams. So let's do that. I might not draw any lines here. So let's find 4 gram at the bottom. This is 4, we'll go all the way up. Go across, that look like 70. 4, yeah, that look like 70. And at 6, go all the way up. It hit the curve, that look like 93. So that's here. So it is what, 93. All right, so let's go back to that. This is 70 and 93. All right, here's how cumulative frequency curve work. So this is cumulative frequency. From 0 to 2 grams is 20 pulses. Now, 20 plus the frequency here supposed to give me the one at 4, which is 70. All right, let's go back to it at 4. Let's go back to it and just 100% ensure that it's 70. So for 4 grams, this is 4. We go up. No, it's not 70, it's 68. More correctly, it's 68. 68. All right, so it's not 70, it's 68. All right, so one more time. The way a cumulative frequency curve works is that you add the frequency as you go down. The first frequency is 20. Then at this level, you're going to add to 20 the frequency for the level at 4, and you will get 68. So it's a good thing we double check, because it means that we would have made an error. So this is 68. Now, what do we add to 20 to give you 68? It means that the frequency here is 48. Now, at this level, 68 plus the frequency at this level will give me 93. All right? So what do we add to 68 to get 93? The answer here is 25. Now, of course, one way we can test if our answer is correct is that n must be equal to the sum of the frequency. So if we add these up, we get, well, if we add up all the way to this level, this is 93. 93 plus 7, this is 100. So when I add up the frequency, I get what, 100. It means more than likely that my answer here and here is correct. Let's complete the question. This is the last part of the question. It says a student is chosen at random, and we're to find the probability that the student estimated the mass to be greater than 6 grams. Well, let's look at this frequency table and see how many students estimate is greater than or equal to 6 grams, greater than 6 grams. It's actually these 7 students. All right. So here the mass starts from what? From m greater than 6, greater than 6. So it's m greater than 6 to what? To 10. So the number of students is 7. So the probability that the mass is greater than 6 is equal to 7 students out of what? 100. Or we could say 0.7, or we could say 7%. So any one of those answers would do. You did not need to write all three. But I normally like to write my probability as a percentage. So there's a 7% chance that if you select a student at random, that his estimate for the mass is going to be greater than 6 grams. All right, and that's the end of the question.